the R behaved. It did what it was supposed to. On chalk, didn't it? The sine theta did not behave. Okay. Warning. Partial derivatives do not behave the same way that ordinary derivatives do, even though we use basically the same rules. And in particular, we write these things as fractions. And the reason is that in Calculus 1, they really are fractions. But in Calculus 3, a lot of times you can't really interpret them as fractions. So if these were really fractions, I could just invert that and invert the other side. So it's a little more complicated than it is over here. Over here we say, where's over here? I don't see any ordinary derivatives. Anyway, dy dx. Dy dx. Oh, we got something called dy divided by something called dx. Most of you would be hard put to say exactly what the somethings are in any coherent logical way. And it takes linear algebra to really make sense out of this. But nonetheless, there's some sense in which you can say, oh, that's a fraction. I'm just dividing. And over here, it just doesn't work out like fractions, except in special circumstances. Sometimes we get to treat them as fractions. When do we get to treat them as fractions? Right now, it's when I say you can. Okay? Now, 3 minutes. I want you to look at the last problem, or the last set of problems. Where did my... Oh, there it is. So I've got... Oh, no, don't look at the problems. I'm going to work a problem sort of like it. Here's an application. PV equals KT. What's that? That's like thermodynamics, okay. P is pressure, okay. Pressure, volume, temperature, and some weird constant. Actually, this constant, if I didn't throw in the mass of that, so I'm lumping in the universal constant with mass. But anyway, forget that. I'm going to think of K as being truly a constant. And here's the problem. Calculate del P del T times del T del V times del V del P equals what? And if this stuff worked like Calculus 1, what answer do you expect to get? 1. Everything would cancel. And I'm going to show you it doesn't turn out to be 1. So let's do del P del T, and what the hell does that mean?
That means the derivative of P with respect to T.
Yeah, but what do I do with that equation up there?
You move the V.
Move the V. Okay, so question mark here. So I've got P equals KT over V. And again, I'm taking the derivative with respect to T, so I'm going to think of K and V as constants. So del P del T equals K over V. All right, so there's one of them. Do the next one. Del T del V.
P over K.
So I'm going to do P over KT. All right. So I solve for
for T.
Solve for T.
I was already thinking.
Yeah, I knew you were, but I was trying to catch up with you. All right. So PV over K, and so del T, and again, we can think of that one as separate. So del T del V equals P over K. Just what he said. then we're gonna solve the other one for V. V equals,
KT over B.
thank you, KT over P, so that's KT times the negative exponent. So del V del P is the
Negative
constant.
KT over P squared.
Okay, K,
KT
P,
over P squared.
yeah, so -1, e to the -2, and then. So putting it all together,
Multi-one.
I've got K over V, I've got P over K, that looks good, and then negative KT over P squared,
One of these.
one of these cancels, and I've got minus KT
Over B.
over P, which is not 1.
Well, technically, it no, it's not.
I know that real volumes and, well, even volume is positive, pressure is positive. Temperature can be negative, but not in this formula, because that's absolute, that's Kelvin
Yeah,
temperature.
it's Kelvin.
All right, so anyway, everything's positive except that minus, so there's no way it's -1.
So you,
I mean, there's no way it's 1. But it is -1, because KT equals PV. I get -1. But that's bizarre. And the last 3 problems on here, contrasting ordinary and partial derivative. By the way, ordinary derivative, that means the calculus 1 derivative. Ordinary derivative means the derivative of a function with only one independent variable. Partial derivative means the derivative of, or a derivative of a function with more than one independent variable. And we have a distinction in the terminology because they behave differently. Ordinary derivatives and partial derivatives. I'm contrasting them. And so you got the same sort of thing here, and I don't really have time to sort of set up these 3 problems, but do it for me.
And you told me to bring up the formula sheet for the test so we can
The
convince
formula
you.
sheet for the test. So she's going to argue with me and get y'all to support her that y'all should get a formula sheet on the exam next Thursday.
Well, it depends on what formulas